G'day chemistry students. In this video we're going to be looking at dot point 3.2.2 and 3, which is all about the reactivity of metals. Let's get into it. So in the last couple of lessons you've been doing a series of reactions with metals. We've already looked at some of those reaction types and the reaction equations, etc. And what we should be realizing is that not all metals react the same. In fact, you can order them by order of activity. And so in class, we're going to be looking at our observations and our results from those experiments and trying to make an order ourselves. But there has been a lot of work done in exploring the reactivity of metals, and there are plenty of sources, plenty of literature data which has already put those metals in order. So we're going to be looking at the data that we've taken and compare it to literature data that you can find online. And an example of a reactivity series is given here, where these guys in red are by far the most reactive metals on the list. The ones in the middle are moderately reactive, and the ones in green down the bottom are least reactive. And you'll notice on the side here where it actually describes reactivity, it helps to sort these into subgroups in which it further describes the type of reactions that occur at each stage of reactivity. Now, the reactivity of series of metals can be explained using a lot of concepts that we looked at for periodic trends all the way back in Module 1. So I want to do a little bit of a quick refresher of that so that we can then look at those concepts in class. So first off, to look at the reactivity of metals, we have to, again, understand that there's a difference in size and shielding of electrons. Because really, when we're looking at a metal reacting, what we're usually seeing is that there is a transfer of electrons where the metal is giving away its electron. So if it's easier for a metal to be able to give away its electron, then it's going to be more reactive. And a lot of the time, electron shielding will come into play. So when we're looking at the reactivity series of metals and metal reactions, what we need to be looking for is our outer electrons and how far away they are from the attracting positive nucleus. And for this shielding that's in the middle, how many electrons are trying to repel away that outer electron or diminishing the positive charge that is in the nucleus. And general rule being, the further out those outer electrons are, the bigger the orbitals of the sp or maybe even d block. The further away that those electrons are, the more shielded the nucleus will be, because there's an increased number of electrons and a further distance between the outer electrons and that middle nucleus. And that leads to periodic trends, all of which are sort of interrelated: the atomic radius, the first ionization energy, and the electron negativity, which all play a part in explaining why we might have a reactivity series of metals. So the radius of a metal atom may contribute to its reactivity, where bigger atomic radii will probably increase the reactivity of the metal. We also have first ionization energy. So these guys over here that have really, really, really low first ionization energies require very, very little energy to actually give away its electron. And if there's a low energy requirement to do that, then that probably means that those metals are going to be the most reactive. We also have kind of the inverse concept of electron negativity, and this is kind of a rating of the atom's capacity to draw in electrons. So again, if we have a low electronegativity, especially for these guys down the bottom, they're going to be the most reactive because they are quite incapable of drawing in electric charge. Now, when we put all of those together, we should be able to explain a lot of these trends. Now, in particular, that's going to be best explained for the ones that are sort of at the top. These are our S block metals, whereas the D block metals don't follow exactly the same pattern, but we can certainly still look at them as a group to explain why their reactivities are lower than the S block metals that you'll see up here in red. Thank you very much, everyone. Now, in the next video, we're going to be looking at redox reactions, which help to even further explain a lot of the interactions and reactions that we've been looking at over the past week or so. And that will sort of lead us into exploring further chemical reactions that involve metals and ionic substances and all sorts of stuff. But until then, have a good one.